Okay.
Okay.
I figured out how to make movies. And it's this cool camera that I figured out I can advance the film, and then I can take a picture. And then I can advance the film and take a picture. So now I'm going to take a movie, okay? So I got these great volunteers who are going to show how this works. So are we ready? Ready to throw the ball? Okay, so we're ready. Throw the ball. Okay, I'm going to take a picture, advance the film. 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 Thank you for the volunteers. Great. Okay, you sit down. Okay, now I'm going to develop that film. I'm going to see what I get. And of course, that ball was moving during my half-second exposure, and so I don't really see a ball, I see a blur. And then, while I was advancing the film, the ball kept moving, so by the time I took the next picture, the ball was in a different spot. I have this time period when nothing was happening. And then I advance the film, and then the ball's over there in that blurry spot. And then I advance the film, the ball's over here, and that's what it looks like, right? And early in the development of motion pictures, they realized that if they did this 24 times every second, it was enough to give you the illusion of motion. But there was a problem. If you projected it like that with frame, black, frame, black, frame, black, the flicker was really annoying. So what they did was they built projectors that projected that same frame twice and with black in between. So instead of flashing 24 times a second, it's flashing 48 times a second. And that's much less objectionable, as long as the picture isn't too bright. If you do this with a bright projector, it starts to be annoying. The eye isn't linear in that respect. So that works pretty cool, all right? And so you start to get something that kind of looks like this. Now you might say, well, that doesn't really look like a moving ball. It looks like 5 blobs on the screen. But if the things aren't moving too much, with that very same frame rate, this is really actually running about 16, you know, that guy looks like he's running. No denying it, the water looks like it's running, even though the baseball looks like a blur. Well, so one thing we could do, I could change my camera here to a different shutter speed, and instead I could go like this. I could have a shorter shutter speed, and I wouldn't get so much blur. Now I start to see the ball if I freeze it. So you might think that's good, but you know, when you see it in motion, it still looks like 5 dots. It doesn't look so much like a moving ball. But for illustration, the wagon wheel does kind of look like it's turning. But now here's the next trick. When I made this graphic, I didn't turn the wagon wheel counterclockwise. I turned it like, well, how many is that? 70 degrees clockwise. And yet it just, your brain says it's turning counterclockwise when it's got that much detail. And to show you how strong that illusion is, I painted some spokes. And even at slow motion, you kind of have to make your rational brain go into action to say it actually did turn clockwise. And when you look at it in motion, it just looks like a mess. All right? I mean, it's turning clockwise, but your brain isn't convinced of that. So a shorter shutter speed can give me more detail, but now what happens to the issue of motion? All right, so that's the quick overview of how film works. And our panelists will fill in and correct me where I got it wrong. What about video? Well, with video, there was no way to like flash the same set of information twice on a television. There was no way to store a film frame to flash it twice. They just had to make that electron beam go, so they couldn't do it at 24, no way. And there was a big advantage of making each picture come up with the power line frequency, so they picked 60 in America. And they also, with the camera, they don't like have to close the shutter to take the next picture and move the film. They can just come right up to the back and scan the original picture tube again, the gathering tube. And so now you've got the baseball still blurs, but doesn't blur as much because you're capturing more often. And there's no gaps between. You don't have any mystery where that baseball was between frames. Okay, that's how video works. And when we wanted to show film on television, now we have an interesting problem because we've got 24 frames per second on that film. We've got television running at 60. What do we do? For those of you who wonder and didn't ever have to deal with this, what we do is we go frame, 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 1, 2, 3, 1, 2. We show each frame 3 times, and then we show the next frame twice, and then we show a frame 3 times. That's what's called 3-2 pull down. That's how film works on TV, and what do we got today? We've got this brave new world. Digital cameras have all these knobs on them. You can do different frame rates, pick your frame rate, 24, 30, 60, pick what you want. You can dial the shutter speed all over the place. However, our broadcast infrastructure is still constrained to 60 pictures a second. But now we've got internet distribution that has flexibility. It can do different things. And now we've got some new televisions that if you feed them 24 frames per second, they actually do some processing and create in-betweeny frames. What do we make of all this? What choices do we make? So that's why we have a panel. They're going to help us answer the questions. I'm going to introduce them as we go along. I'm first going to ask them if I've missed anything important in describing the advantages of a faster frame rate or any other aspects of this. And I'm going to start with our historian, Mark Shubin.